What I got here is a flame detector. This is an infrared flame detection module with potentiometer to set the sensitivity. I got an active buzzer here. I've got an indicator LED and a particle photon. The particle photon will send out a signal to the other particle photon here. This is the receiver. It's got a button with a resistor and a button press LED and a status LED. So, if I take a lighter, you can see that as soon as the flame comes on, the status goes on and the buzzer starts buzzing. Now, for the rest of the demo, I'm going to replace the buzzer with a LED because I don't want to have the buzzing all the time. And what we'll see is once this one activates, the red light on this LED will also activate. That flashing light means it's updating real quick. And that was one of the downsides with particles and photons we talked about, is they can't just continuously run a task like an Arduino does. They do have to every now and then stop what they're doing to continue talking to the internet. Okay, so now, as we can see, our buzzer LED is on, so the buzzer would be going off. The status indicator is on, and the detector light also went on. So if I press the button on the receiver, you'll see this light comes on, but the buzzer light goes off. And that's a built-in feature because one of the most annoying things about fire detectors is the constant buzzing. Even if you know that the fire detector is going off and are actively trying to put fire out, it's kind of annoying to have that going off in the background. So I built this in to get around that, which makes it a superior unit in my opinion. And it sometimes flashes back on, but that's because the detector notices once the fire goes out, it resets, it senses the fire again, and that's what brings the light back on. So as for wiring here, the board has, the IR flame detector board has 4 pins on it. However, we're only using 3 of these pins in this project. We're using the A0 pin, the ground, and the plus pin, positive power. And so for this board, I have the A0 pin connected to A5 on the particle. I have ground connected to ground, and the V in connected to the positive power in to the board. Over here, the status indicator LED is connected to the D7 pin. The buzzer is connected to D6. So I can replace that, and it's the D6 there. On the detector board, it's really simple. You have the positive power coming into the button on the top channel. Then the output comes through a resistor. You can use any resistor value here. You just need a resistor so that the voltage comes to 0 when you get it to the ground, and then just grounds off like the other one. The output on the bottom right of the button goes to pin D6, and then from D6 to ground is where the LED is. And then the status LED here is also on D7. So you can press the button anytime, even if there's not a fire. But if there isn't a fire, it's not going to send a signal to the other photon. It only sends the signal if there is a fire detected. And again, just a demonstration. Indicator on for the buzzer, press the button, indicator for the buzzer goes off, so there's no more buzzing. And with the buzzer, we can see how that is. Buzzer on, press the button, buzzer off. And this is a sample graph of some of the data collected from my fire detector, plotted in real time using ThingSpeak. And on this graph, a higher value indicates the flame is either not as hot or it is further away from the detector.